Okay, thank you. So today we would be start the sixth unit, multiple access techniques. So this is the outlines and syllabus that we have to going to study. That is the multiple access techniques, TDMA, FDMA, CDMA, then spread spectrum techniques, DSSS, FHSS, and then random access techniques like pure and slotted ALOA, and then media access control, CSMA. So start with the little bit introduction of this multiple access techniques. So in real life, we have links with the limited bandwidth, and the wise use of this bandwidth has been and will be one of the main challenges of the electronic communications. However, the meaning of wise here may depends on the application. Means application wise, the uses of bandwidth would be changed. Sometimes we need to combine several low bandwidth channels to make the use of a channel with a large bandwidth. Sometimes we expand the bandwidth of the channel to achieve goals such as privacy and anti-jamming. So these are some applications where we will use the bandwidth of the channel in different ways. There are two broad categories of bandwidth utilization. First one is multiplexing, and second one is spreading. So in multiplexing, our goal is efficiency. We combine several channels into one channel in the case of multiplexing. But in the case of spreading, our goals are privacy and anti-jamming. We expand the bandwidth of the channel to insert redundancy, which is necessary to achieve these goals. So first of all, we have to learn about multiplexing and then go for the spreading techniques. So whenever the bandwidth of the medium linking two devices is greater than the bandwidth needed of the devices, the link can be shared. Means whenever the bandwidth of the medium that would be linked the two different devices is greater than the bandwidth requirement of these devices, so at that time that link would be shared in between two devices. So multiplexing is a set of techniques that allows the simultaneous transmission of multiple signals across a single data link. As data and telecommunications use increases day by day, so the traffic is also increases in the field of telecommunication. So we can accommodate this increase by continuing to add individual links each time a new channel is needed, or we can install higher bandwidth links and use each of them to carry the multiple signals. Means you have to either allocate individual links for each channel, or you can directly take a higher bandwidth link and use to carry the multiple signals. So this is a basic overview how the multiplexing has been performed. Please note down this diagram. So here you can see that dividing a link into the multiple channels. So in this multiplex system, n lines are shared the bandwidth of one link. So there are the n input lines or n signals that would be first multiplexed and then pass through the one link that is having the higher bandwidth that carry this n channels, and then at the receiving end it would be again demultiplexed to the n output lines. So here you can see the lines on the left direct their transmission systems to a multiplexer, and which combines into a single stream, and at the receiving end this stream is fed to a demultiplexer which separates the streams back into its components and direct them to their corresponding lines. Here we are using the link that is a physical path, and the channel could be defined as a portion of the link that carries transmission between the given pair of lines. So on the basis of this phenomena of multiplexing, we would be categorize the multiplexing techniques. So here, as per the categorization, there is a three, that is frequency division multiplexing, wavelength division multiplexing, and time division multiplexing. So first two are the analog in nature, and last one is time division multiplexing, digital in nature. But as per our syllabus, we have to learn FDMA and TDMA only. So start with the frequency division FDM, and then further it would be elaborated as FDMA. So frequency division multiplexing, FDM, is an analog technique that can be applied when the bandwidth of a link is greater than the combined bandwidth of the signals to be transmitted. Means suppose you have n signals and their combined bandwidth is 1 megahertz, but the link bandwidth would be greater than that, maybe 2 megahertz or 5 megahertz. So in this case, we have to use the frequency division multiplexing. So in FDM, signal generated by each sending device modulate different carrier frequencies. Each signal having the different carrier frequencies, and these modulated signals are then combined into a single composite signal that can be transported by that link. And the carrier frequencies are separated by the sufficient bandwidth to accommodate the modulated signals. These bandwidth ranges are the channels through which various signals travel. So here the channels can be separated out by the strips of unused bandwidth, that is called as here guard bands. The guard bands are used here to prevent the signals from the overlapping by the nearby channels. In addition, you can say the carrier frequency must not interfere with the original data frequencies because of this guard bands. So here you can see the FDM multiplexing, where the multiple input lines are applied to the multiplexer that would be combined these multiple signals, and according to this would be modulated by the separate channels, and this would be further demultiplexed into the n number of output lines. And in broad sense, this diagram is a correct representation of the FDM process. Everyone please note it down this diagram. Here you can see that there are the actually you can use n number of signals, but here we have to be represent the three signals having the different properties has been modulated with the three different frequencies f1, f2, and f3, and this modulated waveform or modulated signal would be then applied to the multiplexer, where this multiplexer would be combine these three different modulated signals and then generate a one signal that consists of all these three carriers, and then it would be transmitted through the over the link. So here it is same, whatever I mentioned, that is mentioned in this slide, and then it is sent over a media link that is having the enough bandwidth to accommodate it. Means the media link bandwidth is larger than the bandwidth of the output of the multiplexer. And as we have done the multiplexing, we have to also do the opposite one, demultiplexing process of the same signals. So demultiplexer here use a series of filters to decompose the multiplex signal into the constituent component signals, and every filter having the different tuned at the different frequencies that would be separate out the different carrier signals or modulated signals from their of having the different carrier frequencies. So the individual signals are then passed to a demodulator that separates them from their carriers and passes them to the output lines that is shown in this particular diagram. Also you have to be just note it down. So you can see here at the receiving end, this composite signal has been applied to the or demultiplexed to the different signals that would be passed through a different band pass filter that is having the center frequency, different center frequencies. So in this way, this filter would be separate out these three different signals of having different frequencies, and then that means the frequency of f1, f2, f3 in this case, and then finally it would be series data would be fed to the received as a output signals or baseband analog signal. Okay, so in this way we have seen that how the FDM process has been carried out by the help of the multiplexer and demultiplexer. Now the extension of this would be frequency division multiple access that we have to be learned as far as well. So in the FDMA, the available bandwidth is divided into the frequency bands, and each station is allocated a band to send its data. And in other words, you can say each band is reserved for a specific station and it belongs to the station all the time. Means whatever the station we have allocated, that is having the different bands of the frequencies, and throughout the transmission and receiving, this station would be carry the same band of frequencies. So each station also use here a band pass filter to combine the transmitter frequencies, and to prevent station interferences, the allocated bands are separated from one another by the you can say small guard bands. So it is, if you have to see FDMA, this is the diagram that shows the FDMA technique. So here you can see there is a 4 stations are used, and each station having the separate data. It is please note it down the diagram that it is mentioned as 1, 2, 3 and 4, and that would be transmit their signal or information of different band of frequencies. Like for the station 1 it is shown in the blue color here, for the station 2 it is in yellow, for station 3 it is in the green color, and for station 4 it is in the pink color. So in this way, all stations having the different band of frequencies for the transmission of the data, and then this would be transmitted through the common channel where these 4 different frequency band signals has been transmitted, and each band of frequencies have separated out from each other by the help of guard bands, so that they would be not overlapped or not interfere the each other's information. This in this way we have to be transmit the data in FDMA technique, and from this way you can see that the data stream can be easily used with the FDMA. And we need to emphasize that although the FDMA and FDM means frequency division multiple access and frequency division multiplexing conceptually seem similar, but there are some differences between both the method. So first of all, I have discussed the FDM, and then I am now discussing the FDMA. So what is the differences between both of them? If I have to see, FDM is a physical layer technique that combines the load from the low bandwidth channels and transmits them by using a high bandwidth channel. And the channels that are combined are low pass channels. And here in the FDM, we use the multiplexers to modulate the signals and combine them and create a band pass signal. And the bandwidth of each channel is shifted by the multiplexer. This is that we have to follow in the FDM technique. We use the physical layers, and here we are using the low bandwidth channels, and we have to be transmit with the help of high bandwidth channel and then multiplex it, combine it and create a band pass signal. Okay, and the bandwidth is here shifted by the multiplexer. But in the case of FDMA, on the other hand, is an access method in the data link layer. The data link layer in each station tells its physical layer to make a band pass signal from the data passed to it. And the signal must be created in the allocated band. There is no physical multiplexer used at the physical layer in the case of FDMA. But in the case of FDM, we have to use the physical multiplexer at the physical layer, and we are using the physical layer for the communication. But in the case of FDMA, we have to use the data link layer. So the signals created at each station are automatically band pass filtered, and they are mixed when they are sent to the common channel. So it is just a access method. So this is the basic difference between both of them. If you have to be see, the application of this technique is you can use the FDMA in the AM and FM broadcasting, television broadcasting, as well as the first generation of cellular telephones. Now come for the time division multiplexing, TDM technique. So TDM is a digital process that allows several connections to share the high bandwidth of a link. Instead of sharing a portion of bandwidth, as in the case of FDM, here time is shared, and each connection occupies a portion of time in the link. All the data in the message from the source 1 always goes to the one specific destination. Maybe it is as 1, 2, 3 or 4, and the delivery is fixed and unvarying like the switching. So do not consider that here we have to be given a time division, that it would be act as a switching device. It is not like a switching. Here the delivery is fixed and it is not varying. So that is shown through this diagram. We can note it down. So in this case, you can see that there are the 4 different sources has will be taken for the transmission of the data, that would be multiplexed into the one single data and flow it through the single link that is having the higher bandwidth. And you can see that here each signal of all four sources has been given a time slot during the transmission. So after the completion of all four signals, then again this time slot would be repeated, and it is switching would be happening too much fast, so that it is very difficult to distinguish. And then further at the receiving end, it would be received by the receiver, and then again separate out all these four signals. So in this way you can say TDM is a digital multiplexing technique for combining several low rate channels into a high rate one. Now we would be further elaborate TDM technique into the TDMA, time division multiple access. So in the time division multiple access, the stations share the bandwidth of the channel in time domain. Each station is allocated a time slot during which it can send the data. Each station transmits its data in its assigned time slot. Whatever the time slot is allocated for each station, that station would be transmit the data only on that particular time slot. But if you have to see this technique, the main problem with the TDMA is in achieving the synchronization between the different stations. So this is the diagram that elaborates the concept of the TDMA. If you have to see there again, there is a four stations, there is a four different data are there, and that would be indicated through the different colors, and that would be combined to a single data where this in this link, a common channel, this four data would be transmitted, and each data would be appear at their allocated time slots. And if you have to see in all four channels, there is a only one station that is not, this is silent during the transmission, that is station 3. Means it would occupy the time slot, but does not send any data. It is blank time slot, you can say. So it is very difficult to know by each station. Actually, each station needs to know the beginning of its slot and the location of its slot, but it is very difficult because of the propagation delays introduced in the system. If the stations are spread over the large area, then it is each station having the some propagation delay. So it is very difficult to come to know when the beginning of the its time slot for each station. To compensate for the delays, we can insert guard times, and the synchronization is normally accomplished by having some synchronization bits, that is also known as a pre-ML bits, at the beginning of each slot. Once again, we have to be emphasized that the TDMA and TDM is conceptually looking same, but there is again some differences between both of them. TDM is a physical layer technique that combines the data from slower channels and transmit them by the using a faster channel, and the process use a physical multiplexer that interleaves the data units from each channel. Whereas the TDMA is an access method in the data link layer. The data link layer in each station tells its physical layer to use allocated time slot. There is no physical multiplexer, at the physical layer in the case of TDMA technique. So this is the basic difference. TDMA use the data link layer and TDM use the physical layer. In the TDM we have the physical multiplexers are there, and there is no any physical multiplexer would be used in the TDMA technique. Now come to our next topic, that is code division multiple access. This is also one kind of the multiple access technique. So code division multiple access was conceived several decades ago, but the recent advances in the electronic technology have finally made it implementation possible recently. So the CDMA differs from the FDMA because only one channel occupies the entire bandwidth of the link. In the case of FDMA, we have to divide the channels in different frequency slots, but here only one channel would be occupied whole bandwidth of the link. It is also differing from the TDMA technique because all stations can send the data simultaneously. There is no time sharing in the case of CDMA. So before learning the concept of CDMA, we have to take one of the analogy that how the CDMA would be used. Basically, CDMA means a communication with the different codes. So for example, if you have to see that there is a large room with there are the many people sitting on that, two people can talk in English if nobody else understand the English other than these two people. Another two people can talk in Chinese if they are only ones who understand the Chinese, and there is a so on. Means only a couple of people would be talk in any language if rest of the people in that room would be not understand that language. So in other words, you can say a common channel, the space of the room here can easily allow communication between several couples, but in different language. And in the case of CDMA, this language means there are different codes. So the idea behind the CDMA is that, for example, let us assume we have the 4 stations named as 1, 2, 3, 4 connected to the same channel. The data from that station 1 is D1, the data from station 2 is D2, and so on for all 4 stations. The code assigned to the first station is C1, to the second one is a C2, and so on. So we assume that the assigned codes have 2 properties. First, we multiply each code by another code, we get the result as 0. But if we multiply each code by itself, we get 4. Why 4 here? It is nothing but it could be any number, other number also, but depend upon the number of stations. Here we are using the only 4 number of stations, that's why the result is 4. If we are using the 8 stations, then we get 8, like this. So this has been described through this diagram, that how the communication with the code could be possible. Please note down this diagram. So with these 2 properties in the mind, let us see how the above 4 stations can send data using the same common channel. So here you can see that station 1 having the data D1 and code is C1. So output is D1 into C1, then D2 into C2, like this, D3 into C3, and D4 into C4 for all 4 station output. That is sharing the common channel. So when this data 4 station would be send the data on the common channel, the product of data and code would be added, and then it would be passed through this common channel. D1 C1 plus D2 C2 plus D3 C3 plus D4 C4, and that would become a combined data. So the data goes on the channel are the sum of all these terms. Any station that wants to receive data from 1 of the other three, any station that wants to data from one of other three, multiply the data on the channel by the code of sender. See how this could be possible. For example, suppose station 1 and 2 are talking to each other. Station 2 wants to hear what the station 1 is saying. So it multiplies the data on the channel by C1. It multiply the data on the channel, that is, data on the channel is what? It is a summation of all this station's data, and that data would be multiplied by the code C1, because station 2 wants to hear the talk what the station 1 is communicating. So that's why we are multiplying the C1, the data by the C1. So because we know that C1 into C1 is 4 here, but C2 into C1, C3 into C1 or C4 into C1 is 0 as per the methodology we have learned. So station 2 divides the results by 4 to getting the data from the station 1. You can see here, to listening the what station 1 is saying by the station 2, this data on the channel would be multiplied with the code C1. So we would be get only this is the condition where C1 into C1 it is equal to 4, and rest of the case it would be 0. Okay, so it would be become 4 into D1. Okay, and this would be further divided by the result is divided by the 4 to get the data from the 1. So it would divide by the 4 again, and you would be finally get the data D1. So in this way, station 2 would be listen what the station 1 is saying. So in this way, we have to be communicate the codes over the channel that would be applied by the multiple stations. One more thing in the CDMA, the concept of chips. So CDMA is based on the coding theory, and each stations is assigned a code which is nothing but a sequence of numbers called chips. So it is shown in this case. These are the 4 codes C1, C2, C3 and C4 for 4 stations, and that is having a sequence of number like here C1 plus 1 plus 1 plus 1, that is a chips here. Then plus 1 minus 1 plus 1 minus 1 for the C2 is a chips for the C2, like this C3 and C4. So this orthogonal signal sequences have following properties. This sequence of numbers is orthogonal sequences that is having the following properties. The first property is each sequence is made of n elements. Here the number of elements n is equal to 4. That's why it is a 4 elements, where the n is the number of stations. We are taking the 4 stations only, so here the n is 4. Second property is if we multiply a sequence of number, a sequence by a number, every element in the sequence is multiply that element, and this is called multiplication of sequences by a scalar, because it is multiplied only by a number, so it is a multiply by a scalar. For example, the one of the sequence plus 1 minus 1 minus 1 is multiplied with the scalar quantity 2. So it would be multiplied with each elements of this sequence. So it would become plus 2, minus 2 and minus 2. Similarly, in the third case, third property you have to see, if we multiply, please note down each and every property, that would be useful for further description. If we multiply two equal sequences, element by each element, and add the results, we get the value n, where n is the number of elements in each sequence. This is called inner product of two equal sequences. For example, you can see here the one of the sequence plus 1 minus 1 minus 1 is multiplied with the another sequence, same sequence actually, plus 1 minus 1 minus 1. So here we have to multiply two equal sequences. So it would be multiply each and every element internally. So it would become plus 1 plus 1 plus 1, then plus 1 plus 1 plus 1, minus 1 and minus 1 multiply plus 1, minus 1 multiply again, it is plus 1. Okay. So finally the addition is 4. That is nothing but the number of elements in each sequence. Similarly, the property 4, if we multiply two different sequences element by element and add the results, we will get answer is 0. This is called the inner product of two different sequences. You can see here the same case that I have shown here. Two different sequences, multiply element by element, finally would we get the result is 0. The fifth property of the orthogonal sequences are adding two sequences means adding the corresponding elements. So the result is another sequence. So addition of two sequences become the results of another sequence. So here you can see here that element by element or position by position addition is there. That would be followed here. And finally you will be get the result is the another sequence plus 2, 0 and 0. Okay. So these are the 5 properties of the orthogonal sequences, and then further we can see how to represent this data or codes. So we follow these rules for encoding that we have learned the 5 rules for encoding. So if a station needs to send a 0 bit, it encodes it as -1. If it needs to send a 1 bit, it encodes it as a +1. If when a station is idle, it do not send any signal, it is interpreted as a 0. This is the data representation in the case of CDMA technique. By the use of this encoding method, we have to do the further encoding and decoding of the so we have here 4 stations that is sharing during the sharing the link during the 1 bit interval. Please start to fill up the attendance simultaneously. We have only 1 minute left. So we have to be stop on this point encoding and decoding. Tomorrow we have to be learn this. For the sake of time, you can take the screenshot of this diagram or draw this. That would be discussed tomorrow. Encoding and decoding. And then after this CDMA, we have to be enter into the topic of spread spectrum and PN sequence. That is also we have the practical. Okay. Thank you all of you for attending the lecture.
तर काय खाल्ले तुम्ही काय केले